All right, so the focus of our lesson today is the distributive property. So the distributive property is a multiplication type property that states that if you ever put a number, say we have a factor outside of the parentheses, and multiple numbers inside this, the distributive property says that you must distribute the factor outside and multiply that number by everything inside of the parentheses. So here, there's two numbers inside, so I need to do 5 times x, which is 5x, and 5 times 4, which is 20. So that's the distributive property. I'm distributing the factor on the outside times each thing on the inside. And so when we first were learning about the distributive property, we were using area of rectangles to kind of visualize this concept, okay? So if we're going to talk about the area of rectangles, it's important to have that formula in our heads. So the formula for the area of a rectangle is area equals length times width, all right? So number one, select, once again, there's that bold all. Select all the expressions that represent the area of the large outer rectangle in figure A. Explain your reasoning. So essentially, they're saying, what is the area of this entire rectangle? Not just this one, not just this one, but the whole thing together. So area equals length times width. So we'll call this our length. So the length is 6. All right, awesome. That's pretty easy. But now the width is 2 different numbers. So if I'm doing both of these things, I could say 3 plus 2 together. I know that's 5. So 6 times 5 is 30. And I can see right here, that's an option. Another way of doing it is if I multiply this length times this rectangle, so length times width, 6 times 3 is 18, and then 6 times 2 is 12, and if I put those two things together, 18 and 12, guess what? I get 30. So same thing there. So that is like B, where 6 is multiplying by this rectangle, 6 is multiplying by the width in this rectangle, and then I'm putting them together to get the same answer. And now, the other one that would work would be E, and this is that distributive property concept that we talked about, where once again, if you ever have a number on the outside, that number on the outside is actually multiplying by both numbers on the inside. Once again, we get 18 and 12, and we get 30. Okay? So in every situation, we're just getting the same thing, whether we multiply by the two rectangles individually and add them up, or if we just add these together from the get-go like we did in the first place and got 30. Either way, same thing. All right? Now, 2, same thing, but now we're going to be focusing on this shaded rectangle. So here, we were looking at the whole thing. Here, we're looking at a part of something. So, if this one was addition, this one is going to be subtraction, because I don't want to do 4 times 7. Because if I did 4 times 7, I'd get 28. The problem, that's this whole thing. The area of this whole rectangle is 28. But I don't want this white part. I only want the blue part. So, what is, if the length of this whole thing is 7, and this is 2, what must this be? Well, that's where our subtraction comes into play. So 7 minus 2, if this is 2, then this blue must be 5. So 4 times 5 would get me my answer. Alright, so I can see that's right there. D would also give me my answer, because D is finding the area of the whole thing, so that 4 times 7, which is 28. And then, so the area of this whole thing is 28. And then the area of this 4 times 2 is 8. So if I found the area of this whole rectangle and then subtracted this portion from it, like I'm doing here, 4 times 7 is 28, and then 4 times 2, which will give me the area of the white part, I would also get 20. And once again, we're going to do that distributive property. E would also give me the same thing, because once again, I'm distributing through both, multiplying by both, and I would also get 28. Minus 8 is 20. Okay, so these are the three that would work. F would not work because you're not adding those two areas together. That would be finding the area of this whole thing and then adding the area of this on top of it. So no. This one is not correct because order matters in subtraction. So this one is finding the area of the white rectangle and then subtracting this entire area. That would actually be a negative number, so that wouldn't make sense. And here, 4 times 7 is 28 times 2 is 56. So that would not give us that area of 20 that we've been looking for. And once again, here, this would be finding the area of the whole thing. 4 times 7 is 28. And then adding this area on top of it. So if 28 is already the area of this whole thing, including this, we would not want to add this again. So that's why C, D, and E were the only answers that made sense there. Okay, so on this next page, they want us to just kind of do the same thing and write an explanation. So why is this the area? So 6W minus 24. So if you want to pause the video now to answer this question and give it your best shot and say why both of these expressions would be the area for this, go ahead and do that now. And now we will go over it. So 6 times W, so this whole thing is W. And then 24, where's that 24 coming from? Maybe, let's look at this one first. So 6 times W would be the area of this whole thing, right? Because 6 is the length, W is the width. So if I did that, that would give me the area. The area of the whole thing is 6W, but I want to subtract this section. So I would also have to find the area of this before I could subtract it. And 6 times negative 4, or sorry, 6 times 4 is 24. So we're finding the area of this whole rectangle and then subtracting this portion from it. So what's important to know is, and we can see here, this was the equation that I was given originally. So once again, if you want to find the area of just a small section of the shaded portion, then a lot of times you'll have to find the area of the whole thing and then subtract the piece that you don't want. And once again, the idea of the distributive property, these are the same thing. Down below, if W was 10, then what would the area of the shaded area be? So, once again, so here they're giving us a value, they're giving us values for our variable, so then that means that we would need to substitute as it says. Anytime you're given a value for a variable, you substitute it into your expression to get an answer. So if W was 10, so instead of 6W minus 24, it would be 6 times 10 minus 24, which would be 60 minus 24, which would be 36. It didn't give me a unit, yeah, it did, centimeters. So anytime we're talking area, it's got to be that unit of measure, and it's got to be squared. And what about if W was 44? So same thing, but I'm just replacing W instead of here, I replace W with 10. Here I'm substituting in 44. 6 times 44 is, what, 264, I believe. Yes, 264 minus 24, and that would give us 240 centimeters squared. All right, so just to, once again, get that extra practice of substituting in values for variables. All right, and now to the next page. So here we have a series of rectangles, A, B, C, D, E, and F. So the table has those labeled, and now you need to find the width and length of each of them, and then we need to write the areas down. So let's start by just doing A together. So we'll say the width is 3, and the length is A, and it's 5. So we can just write A plus 5. All right. So now the area is a product of length and width. So that would be the length and width times each other. And then area is the sum of the areas of the smaller rectangles. So this is after I do the distributive property, 3 times A is 3A, and then 3 times 5 is 15. Right? So that means the area of this tiny rectangle is 3A, the area of this is 15, and I put them together to find the area of this whole thing. 3A plus 15. So B, 1/3 times 6 plus X. So then we could write this as a distributive problem again. Now we have to multiply through, so 1/3 of 6 is 2. 1/3 times 6 is 2. And then 1/3 times X is 1/3 X. Okay? So at this point, if you would like to pause and try and complete the rest independently, that would be great. Otherwise, now I am going to go through and solve those so that when you're done working independently, you can finish the video to check your work. So here, width is R, length is 1 plus 1 plus 1. So there's 3 separate triangles. So to write that distributively, could write it like this. And then, so that means that the area of each, R times 1 is R, R, and R. So if I distributed this, it would be R plus R plus R, which could also just be written as 3R. Simplify it, right? So remember, repeated addition is really just multiplication. R plus R plus R is the same thing as 3 times R. And then let's just get through these next couple. Width is 6, length P plus P plus P plus P. Here is it as a distributive property problem. If I distribute that through, so the number on the outside multiplies by each number on the inside, 6 times P is 6P, and it's just doing that all of those times. And if I added those all up, this would be 6P, 12P, 18P, 24P. That should be our answer there. Okay. M, 6 plus 8 for E. That would be, this is a distributive property problem. M times 6 is 6M. M times 8 is 8M. Since they both have M's, they can actually be added together, and that would be 14M. And then the final one, 5, is the width. The length is 3x plus 8. That's distributive. Find the area of the whole thing, right, like that. 5 has to multiply in by each of those. 5 times 3x is 15x, and 5 times 8 is 40. I cannot combine these terms. So in the previous 2 problems, I combined them because they were like terms. Because all of these had a p, I could add them all up to get 24p. And because these both had an m, I could add them up to get 14m. In this problem, 15 has an x, but 40 does not, so I need to leave them like that.